This Rate Super FRQ is going to take us through some commonly asked rates questions. In this particular question, we have coal that is burning in a furnace, exhausting the resource. We're told that the rate at which the coal is burning, that's a key word for us right there. And also what confirms that rate is that this is given in pounds per hour, which is a rate type of unit. It's given as B of T. So that's the rate of removal because that coal is burning, so it's removing that amount. And at T equals 2 hours, we have a worker that's adding to the pile of coal. So we have a rate of adding the coal is S of T, and again, pounds per hour tells us that is a rate. This is a calculator active question, and for any calculator question, you're going to want to take these functions. You're going to want to store them into Y1 or F1 and Y2, F2, and it's always nice to put it on your paper that I have this in Y1 and I have this in Y2. In part A, I'm asked for the total amount of coal in pounds that the worker adds to the furnace. Just a reminder of the progression of things. We go from pounds, which is an amount, to pounds per hour, which is a rate, to pounds per hour squared, which is a rate of a rate, also known as acceleration. So these rates that are given up here, they're given in pounds per hour. So I'm sitting here at this level. If I want to get back to pounds, because that's what the question is asking, what I need to do to move upwards in this list is I need to integrate. So if I need to move down in this list, I'm going to do a derivative. If I need to move up in this list, I do an integral. So from pounds per hour back to pounds, I'm going to integrate. My rate of adding is starting at T equals 2 and continues until T equals 5. So my limits go from 2 to 5. And this is just the rate of adding the coal, which is S of T. And I would advise calling it by its name. Don't write that actual function there. It's not wrong if you do, but it just takes more time to do that. And then you just put that in your calculator and you get this as your answer. Make sure you go 3 places out. Either rounded or truncated is fine. There's nothing indicating you have to say the units. So I wrote pounds, but you don't need to. In part B, I'm asked how many pounds of coal are in the furnace at T equals 5. So I need to consider 3 things. Number 1, how many pounds of coal started at T equals 0, and that's given as 500. How many pounds are being added, and that's pretty much what I did in part A, which was that integral. And then how many pounds are burning, and that's given by this B of T function, and that begins at 0, so my limits go from 0 to 5. B of T dt, and I put that in my calculator and I get that 512.803. I am asked to give this to the nearest whole number, so I'm going to use traditional rounding rules, and that 8 is going to make that 512 turn into a 513. Another way you could have done this is in place of this integral right here, if you just wanted to pull that number down, since it's the same as we found in part A, it would be fine to just put that value in. Part C is asking, is the amount of coal in the furnace increasing or decreasing at T equals 4? The way that you tell if an amount is increasing or decreasing is you look at its derivative, that is the rate at T equals 4. So I used B of 4, so this is my removal rate at 4.7558 pounds per hour. I find the adding rate, which is 6.742. And if I am adding faster than I am removing, what that means is that my amount is going to be increasing because S of 4 is greater than B of 4. And also remember, when you're calculating what these rates are, you're not typing that function in again because you've already got it stored into Y1. So on your home screen, you just do Y1 of 4 and Y2 of 4 to get those values. In part D, I'm first asked to find S prime of 3. And again, because I have that function S stored into my calculator, I'm just going to use my calculator to find that derivative. And that gives me a value of negative 5.016 or negative 5.017, depending on if you round or truncate. Next, I'm asked to explain the meaning of this derivative in the context of the problem. Function S is given as the rate that coal is being added. So when I do that derivative of that rate, I'm finding the rate of the rate. So here is my explanation. So I've got the rate the coals being added is decreasing at a rate of, and I went ahead and incorporated that actual value into my answer. And if S is in pounds per hour, that means S prime is going to be in pounds per hour because we're at that acceleration level. And then I have to include what the 3 means, and that is just at that moment in time, at 3 hours. One thing I want to point out about this explanation is if I change the wording slightly and said the rate at which the coal is being added is changing at a rate of, I would have put the negative on my value right here because I'm not given a sign to it. By saying decreasing, I'm implying it's negative. But if I say just changing, then I need that negative there to indicate that. In part E, I'm asked to write a piecewise function and call it A of t that gives the total amount of coal in the furnace at any time between 0 and 5. What's different in that time interval from 0 to 5 is that there's a worker that starts adding the coal in at time 2 and runs till 5. So that's where the 2 different functions are going to come in. So between 0 and 2, all that I have happening is the 500 pounds that are there to begin with. And then I have that removal rate that the coal is being burned that's applying from 0 to 2. From t equals 2 to t equals 5, I have a third action to consider. So I have my 500 pounds that I start with initially. I am removing from 0 to 5. This will give me the total amount that has been burned. Plus, now I have this amount here that the worker's adding from 2 to 5. In part F, we're asked at what time does the amount of coal hit an absolute maximum, and also the amount of coal in the furnace at that time. A couple things that let me know what to do. Whenever you have a closed interval, and I know that because these inequality signs are underlined, and also ask for an absolute, that is a signal that you're going to do a candidate's test. So I need critical points and end points. So my critical points are where the derivative, and don't forget the rates are derivatives, where this derivative equals 0, and that ends up being, just imagine that minus b of t moving over. It's where s equals b. So I would look at my graph on my calculator and I would find that intersection point. It is always a good idea to store these decimally numbers. I stored it in a value called a, and since I've made that definition on my paper from now on, I'm going to refer to that value as a. You don't have to store it, but if you do not, make sure that you carry this number out more digits to use in a further calculation. So that is the first number that's going to go in my sign chart. And then I also have to consider my endpoints. That is the 0 and the 5. So there is my list of candidates. To determine which one of these is the absolute maximum, I'm going to find out the amount of coal in the furnace at each of these times. And I'm going to use this little formula over here to do it. It's basically what I did in one of the previous parts. This answer, 553, is what I get when I plug my A in for my upper limit, so from 2 to A. And this is starting at 2 because that's when the worker starts shoveling coal into the furnace. And this one goes from 0 to A because it's burning that entire time from 0 to this time. So that leaves me 553 pounds. At t equals 0 was my initial amount, which was just 500. And at t equals 5, I answered that in a previous part, so I'm just going to pull that answer down. This tells me that my maximum amount is here at the 553, so I just say that is my answer. Make sure when you declare your answer that you address all parts of the question. It wanted to know at what time we hit that maximum. That is answered by saying t equals a. It also wants to know the amount of coal, and that was the 553. And also make sure you follow any directions about rounding. This one asked me to round, so I had to make sure I did that. In part G, I'm first asked to evaluate this integral here. So that's pretty much just typing that thing into my calculator and coming up with that answer. Next, I'm asked to explain the meaning of this integral. And just like an explanation of a derivative, I need 3 components to this: what it is, a unit, and what the limits mean in the context of the problem. There is something in this problem that gives away what it is, and it's this fraction here in front. If you have a fraction in front of your integral, and what you're subtracting down here matches the limits, what that means is you're going to be finding an average value. So let that be your clue that this is an average value. and what it's the average value of is whatever your integrand is. So this is the average value of S, and S is given as the rate at which coal is being added. So that is the first part of my explanation. That's the what, the average rate that coal is being added. And that rate is given in pounds per hour, so I include that in my explanation. And my time interval from 2 to 5, which are just the limits that are used right here. My last part here in H says that after 5 hours, no more coal is being added, but continues to burn. Write but do not solve an equation involving one or more integrals that gives the time t equals k where the coal is all gone. In this problem, we're using our times as the limits of our integrals, so that k is going to appear as a limit. And just my thought process behind this, I'm going to start with however much coal I had at t equals 5 hours, and then I'm just going to keep that removal rate going from 5 until k until I hit 0. So here is my amount at t equals 5. I just imported that answer from part B. And then my removal rate is going to continue from 5 until sometime k until I have 0 amount of coal left. An alternate way of doing this is like this, and you could just imagine that integral being moved to the other side. So you want this removal process to keep going from 5 until k until I hit that 512.803 pounds. These rates questions are frequently asked on the calculator portion, so you're going to want to make sure you can use your calculator for you. Make sure that you store any rates into Y1, Y2, or F1, F2 if you use the Inspire. And also let the calculator do any derivatives or integrals or solve equations for you. Just make sure that those items show up on your paper.